understood due to their simplicity, ease of implementation, and effectiveness for a broad range of applications. So, syempre po dahil conventional, siya po ay medyo versatile. And marami po siyang pwedeng maging uses, and aside from that is very simple po yung kanyang system. Conventional control techniques typically involve the use of straightforward mathematical models and control strategies. So unlike po sa adaptive kanina, na nag-a-adapt na siya kung sakali man pong magkaroon ng mga unprecedented events sa loob ng ating system. Si conventional po kasi, straightforward siya in terms na kung ano sa tingin natin yung dapat na maging takbo ng system is iyon lang siya. Hindi siya prepared sa mga unprecedented events, sa mga disturbances, kasi nga po siya ay conventional. Conventional control systems use fixed control parameters that do not change during operation. These parameters are typically designed based on the expected behavior of the system. An example of this is a PID controller or the proportional integral derivative controller, wherein the gains Kp, Ki, and Kd are set initially and remain constant throughout the operation. So ano nga po ba ang PID controller? So a proportional integral derivative controller or PID controller or three-term controller. Bakit po siya three-term? Kasi meron pong distinguishing feature si PID controller na kaya po niyang gamitin yung tatlong terms niya, which are proportional, integral, and derivative, para po makapag-apply ng accurate and optimal control. So it is a control loop mechanism employing feedback that is widely used in industrial control systems and a variety of other applications requiring continuously modulated control. So ano po ba ang ginagawa ni PID controller? So meron po tayong tinatawag ni error value or the ET. So it is po the difference between our set point or yung kung ano man yung gusto po nating value or yung ating desired or yung ating input subtracted po sa ating process variable PV or YT, or in other terms which is the output. So again po, the error value is the difference po between the set point and the process variable and applies a correction based on proportional, integral, and derivative terms. So, ang gagawin po ng PID controller natin is isusubtract po niya or kukuhanin po niya yung error value through the subtraction of the set point or the input and yung measured value which is the output. Siyempre po, mag-a-apply na rin siya ng correction doon po sa error value through the use of the PID controller or yung proportional, integral, and derivative controller. So what po is the difference between a conventional and an adaptive control? Conventional po is a system which uses fixed controller parameters that do not change during operation. Kasi nga po, siya ay fixed na. So, ina-assume po ni conventional control na kung ano yung sinet nating parameter sa kanya ay yun at yun at yun ang magiging loop ng system. Si adaptive naman po, continuously adjust their parameters in real time based on the observed behavior of the system. Kung sakali man po na nagkaroon ng unprecedented event, tapos nagkaroon ng error in between the set point and the measured variable, is kaaya pong mag-adjust ni adaptive by sending parameters lang po sa ating controller. Conventional control strategies are designed based on a model of the system that is assumed to be accurate. The performance is typically evaluated under the assumption that the system dynamics are well understood and stable. Tulad po ng nabanggit ko kanina na sa conventional control system is ina-assume niya na yung system po natin ay magre-run normally. Wala siyang magiging problem. And kung ano yung sinet natin sa kanya is, yun lang po yung mangyayari. Adaptive control systems use algorithms to learn from the system's behavior and adjust their parameters accordingly. So this is what we call a control law. Yan po yung mga mathematical formula or algorithms na nakakapagbigay po ng mga dapat na adjustments or gawin dun sa ating controller to suffice po dun sa mga nakuha niyang error. Next po is a conventional control which does not adapt to changes in system behavior or external disturbances once the system is in operation. It relies on accurate initial design and parameter tuning, while adaptive control is specifically designed to handle situations where system dynamics are uncertain or vary over time. So, syempre po, mag-focus po tayo sa kung ano yung mga kayang ibigay ni adaptive control. So, si adaptive control po ay meron din po siyang factor such as system identification. The field of system identification uses statistical methods to build mathematical models of dynamical systems from measured data. So, ano po ba ang ginagawa ng system identification? So, gagawa po siya ng system from the measured data or yung relationship po between the input and the output or the set point and the measured data. This process involves creating models that describe the relationship between inputs and outputs of a system, allowing for better understanding, prediction, and control of the system. System identification is crucial in fields like control engineering, signal processing, and machine learning. So, ano po ba ang steps in system identification? Kung nakikita po yung picture, so meron po tayong mga boxes or block diagram na meron pong arrow na nagko-connect into system identification and sa model. So, the first process po or the first procedure in system identification is data collection or yung input or output data. So, we have to gather input or output data from the system na gusto po nating magkaroon ng model. This typically involves applying known inputs to the system and measuring the resulting outputs. Next po is the parameter estimation. The use of collected data to estimate the parameters of the chosen model. So, marami po tayong klase ng methods na pwede po natin gamitin in parameter estimation. Next po is we have the model validation. Assess the accuracy of the model by comparing its predictions with the actual system behavior. So, titingnan po natin gaano po ba ka-accurate yung ating mga assumptions sa kung ano talaga yung nangyayari sa loob ng ating system. Kaya nga po from the word identification, so tinitingnan po natin ano yung data or the difference or the error between the input and the output po natin. And the last po is model refinement. Based on the validation results, refine the model by adjusting parameters, choosing a different model structure, or incorporating additional data. So, marami po tayong klase ng system identification. So, we have 3. From input to output, we have what we call the white box, the gray box, and the black box. So, ano nga po ba si white box? So, kitang-kita naman po natin sa picture na si white box ay nakikita natin yung loob. White box model system identification is a method of creating system models based on detailed knowledge of the system's underlying physical principles or structures. White box models incorporate known system dynamics and relationships into the modeling process. Ibig sabihin po, lahat po ng factors sa loob ng ating system ay alam natin in a white box model system identification. So, pwede po nating i-consider dyan yung mathematical equations na ginamit natin for the system, We can also consider the gears, the levers, the motors, or yung resistance or capacitance ng ating mga electrical wirings. Ano naman po ngayon yung tinatawag nating black box? Kung nakikita po natin yung picture sa black box, talagang black siya, so hindi mo nakikita yung loob ng ating system. It is a method of modeling dynamic systems where the internal workings or mechanisms of the system are not known or considered. Black box models are data-driven and do not require detailed knowledge of the system's physical or internal structure. So, ang focus lang po ng black box system identification ay yung input-output data. So, hindi na po niya kinoconsider yung laman nun sa loob, sa kung ano man po bang gear ang gamit niya, anong levers, anong klase po ba ng wirings meron, kaya po siya black box. Kasi po, ang factor na kinoconsider lang niya ay yung panlabas na kaanyuan ng atin pong system, or again, yun nga pong input or output niya. And then, the last po is we have the gray box system identification. So, ano po ba ang kulay na kalalabasan pag minix po natin ang white saka black? Yun po ay gray. So, si gray box identification system or system identification is a modeling approach that combines elements of both white box and black box methodologies. It leverages a combination of physical knowledge and empirical data to create models that are more accurate and robust than purely black box models, while still being less complex than white box models. Kasi po si black box system identification, medyo nasa side siya ng maraming pagkakamali since hindi po natin consider kung ano yung nasa loob ng system natin. Samantalang si white box system identification naman po, syempre mas complex siya kasi kailangan natin i-consider yung labas, yung input and output data, and yung mismong mechanism sa loob ng ating system. So, kapag kinumbine po natin sila, is nagagamit natin yung advantage ni black box and yung advantage din ni white box nang hindi naman po ganun ka-complicated yung nagiging system. And then, the next po that we have is parameter estimation under po ng adaptive control pa rin. So, what is parameter estimation? It is a crucial aspect of adaptive control and system identification, aiming to determine the parameters of a system model based on observed data. So, from the word estimation is nag-estimate po tayo ng ating parameters, which is a combination po of adaptive control and system identification. Accurate parameter estimation allows for the development of controllers and models that can adapt to varying conditions and improve system performance. Ano naman po ang applications ng parameter estimation? First po ay control systems. Adaptive controllers adjust their parameters based on estimated system dynamics. Next po is signal processing. Parameter estimation is used in filtering and signal analysis to model and predict signals. Next po we have economics and finance. Estimating parameters in economic models or financial systems for forecasting and analysis, which I think is kailangan din po in a manufacturing industry since dapat po ay marunong po tayong mag-forecast. And last is biology and medicine. So, modeling biological systems or medical processes where parameters need to be estimated from experimental data. Next po that we have are the classifications of adaptive control. So, sana po ay wala pa pong questions so far. So, for the first classification po is we have the indirect. So, from the word indirect po, hindi siya direct. So, hindi po siya kaagad-agad dumidiretso. A specific type of adaptive control where the adaptation mechanism involves estimating the parameters of the system and then using these estimates to adjust the control law. So again po, what is a control law? It is a mathematical formula or algorithm used to determine the appropriate control actions based on the system's current state and estimated parameters. So, ibig sabihin po, ang control law, yan po yung gumagawa ng formula or siya po yung gumagawa ng parameter na dapat pong maging adjustment ng ating controller as kung ano po yung nakikita niya na relationship po or error between the input or the output. So, syempre po, we have the set point or yung atin pong input again. And we always have our output. And ang gagawin po ng ating controller ay meron siyang estimator na tinatawag. So, ano po yung ginagawa ng estimator? Or pwede din po natin siyang tawaging observer. It monitors the system's input and output to estimate the plant's parameters. So, all in all po ay ini-estimate lang talaga niya yung difference between the set point and the output. Ngayon, kapag meron na po tayong estimation ng plant parameters, yun po yung gagamitin ng ating calculator para makapagbigay ng instruction kung ano po ba ang dapat gawin. Kailangan po ba nating initin pa rin yung ating heater? Or kailangan na po ba siyang patayin? Kailangan po bang maglabas ng water? Puno pa rin ba? Or sakto na yung level ng water sa atin pong water tank? So, what are the advantages po of indirect adaptive control? We have handles uncertainty, effective for systems where the parameters are uncertain or vary over time. The adaptive nature allows the controller to adjust in response to the changes. Next po ay improves performance by continuously updating the control law based on parameter estimates. The controller can improve system performance and maintain stability. Kasi nga po ang ginagawa natin is meron po siyang estimate. And next is flexibility. The indirect approach provides flexibility in control design and can be used with various types of plants and control laws. So, syempre po, kung meron tayong indirect, ay meron din po tayong direct. So, direct adaptive control is another approach to adaptive control where the controller adjusts its parameters directly based on the observed performance of the system without explicitly estimating the plant's parameters. So, ang difference lang po niya, kanina meron po tayong nag-estimate, ngayon po ay wala na. So, direct na. Meron po tayo ulit set point or the input. We then again have the output and i-check po nung ating calculator yung difference or i-compute niya yung difference between the set point and the measured value. And then, through that po ay magsisend siya ng control parameters to adjust the error na meron po sa ating system. So, what are the advantages po of direct adaptive control? First po is simplicity. So, kung titingnan po natin yung difference ng direct sa indirect, talaga naman pong mas simple. Kasi wala ka naman na pong ilalagay. Ang kailangan mo lang po ay controller. Siyempre, you need the sensor, the process, the input, the output, and yung inyong calculator. Tapos, okay na siya. Gagana na po yung ating system. Continuously measure the system output and compare it with the desired reference or trajectory. Next, for real-time adjustment, it can provide real-time adjustments to the control law based on system performance, potentially leading to faster adaptation and reduced complexity, which is, I think, medyo related po sa ating first advantage. Since it does not require explicit modeling of the plant, it may be less complex than indirect adaptive control. So, for the first classification po, again, we have the indirect. Next is direct. And the third one po is what we call hybrid. Or hybrid adaptive control is the combination po of both direct and indirect. This approach utilizes parameter estimation and direct modification of the control law to achieve better system performance and robustness. So, pasensya na po kayo, wala po kasi ako makitang photo ng hybrid adaptive control. So, i-discuss ko na lang po siya kung paano po siya nangyayari. Kung naaalala niyo po yung difference between direct and indirect, si indirect po ay merong estimator. Si direct naman po ay wala, diretso po siya kaagad na calculator. So, paano po nangyayari si hybrid adaptive control? So, meron po tayong indirect adaptive control technique na ginagamit yung estimator. So, nag-estimate ka po ng system parameters at kasabay po ng pag-estimate natin ay nag-a-adjust po real-time yung ating control law based po sa performance or sa error signals ng ating system. So, sabay po siya. Hindi ka lang po nag-estimate and then after nun, meron pong magko-compute or nagko-compute na po kaagad, sabay siya. Meron nang nag-estimate, meron pang nagko-compute. This adjustment can help to quickly address performance issues that arise in practice. The control law is updated based on a combination of estimated parameters and real-time performance metrics. So, kukuhanin po natin yung mga na-estimate natin na data between the set point and the measured and kung ano yung real-time na na-measure po or real-time data between the input and the output. So, doon po magbe-base yung ating control law sa kung ano man pong control parameter yung isi-send niya pabalik kay controller. So, the advantages of adaptive control ay enhanced performance. By combining parameter estimation with direct adaptation, hybrid adaptive control can achieve better overall performance and robustness. Next is flexibility. It can be adapted to different types of systems and operating conditions, providing a more flexible control strategy. And the last po is improved stability. Incorporating elements of indirect adaptive control can help ensure stability, while direct adaptation can address performance issues in real time. I hope po ay wala po pong questions so far. Next po, that we have are techniques kung paano po nagkakaroon ng adaptive control or kung paano po siya ginagawa. First po is we have the feedback adaptive control. Feedback control is an extremely common method for driving a system, usually consisting of an input data point or set point, an output, a process, sensors, and a controller. With these components, one can create a closed-loop system that senses the effects of the output from the controller. So, para lang din po siyang isang basic process control system. So, for an example po, we have here a temperature control system. So, ang una po natin dapat i-consider ay yung atin pong process. Ano po ba ang process natin in a temperature control system? So, syempre po ay controlling the temperature of the water. Next po, that we have is what we call the output. So, for this case po, ang output natin ay yung ating heater. And then, next po, we have the feedback controller. So, pwede po natin gamitin yung PLC. So, syempre po, meron din po yung sensor. And then, we have the input. Or yung input po natin is the desired temperature. So, for an example po, ang desired temperature ko po ay 100 degrees Celsius. Pero po, ang current na temperature natin ay nasa 60 degrees Celsius pa lang. So, ano po yung gagawin ng ating feedback controller? So, syempre po, i-check po niya, hindi pa pala nare-reach yung 100 degrees Celsius. So, dapat si heater po natin naka-on pa. So, maglulup lang po ng maglulup yung procedure na yun hanggat hindi po nare-reach yung desired temperature natin na 100 degrees Celsius. The goal is for water temperature to reach the set point without overshooting. As the control system changes the output, the change could be the percentage of water or of what power of the heater or the sensor reports back to the control system any change in the system. Next po ay yung categories ng feedback adaptive control. So, meron po kasi tayong dalawang categories ng feedback adaptive control. We have the dual and the non-dual. So, from the word dual po, ibig sabihin dalawa, are based on dual control theory, which is a branch of control theory that deals with the control of systems whose characteristics are initially unknown. So, ibig sabihin po, hindi natin alam kung ano po ba yung characteristics ng ating system. It is called dual because the controller's objectives are twofold. So, kaya po niyang mag-action and investigation. So, for action po, it is the control law. So, ito po, again, yung nagsisend or gumagawa ng mga mathematical formulas or algorithms na magbibigay po ng control parameters dun sa ating controller. So, habang kaya po ng ating dual adaptive controllers, yung action ay mayroon din siyang investigation or yung learning mechanism na tinatawag. Kapag po sinabi nating action, to control the system as well as possible based on current system knowledge. And kapag naman po investigation, to experiment with the system so as to learn about its behavior and control it better in the future. So, ibig sabihin po, hindi lang tayo nagko-control. Naglo-learn pa rin po yung ating dual adaptive controller. In dual control, the control strategy is designed not only to regulate the system, but also to gather information that helps refine the system model. So, hindi lang siya nagko-control, hindi lang po siya nagsisend ng signals, naglo-learn din siya para po if ever na magkaroon po ng mga pagbabago doon sa ating system, ay kaya pong mag-adapt ng ating dual controllers. Next po that we have is the non-dual, which refers to control strategies that prioritize immediate control objectives without simultaneously addressing the issue of system identification or parameter estimation. In other words, non-dual control focuses exclusively on controlling the systems effectively using the available model or knowledge. So, si non-dual adaptive controllers po ay meron pa yan dalawang klase or dalawang forms na tinatawag. So, first po that we have is the MRAC or the Model Reference Adaptive Control. It is a type of adaptive control strategy designed to handle systems with uncertain or varying dynamics. So, pwede po hindi din natin alam kung ano yung component sa loob po ng ating MRAC. MRAC aims to adjust the control parameters in real time so that the system's output closely follows the output of a reference model which represents the desired system behavior. So, bukod po sa ating set point, ay meron pa po tayong reference model. Ano po ba ang reference model? It is a model that represents the desired performance or behavior of the system. Ito po yung tinatawag nating reference model. So, syempre, siya po yung nagbibigay ng set point or ng input kung ano po ba yung desired natin na mangyari dun sa ating system. And aside from that po is we have the adjustment mechanism. So, sa adjustment mechanism po ay kukumputin po niya yung difference between the set point and the measured value or again po yung atin pong input or output. So, kung malayo man po yung nakuha nating error doon sa ating reference model ay magbibigay po ng parameter yung ating adjustment mechanism doon sa ating controller. Ano po ba yung dapat niyang gawin para po sila ay magtugma ng ating reference model? Next po that we have is the MIAC. Kanina po MRAC, ngayon ay MIAC. Model Identification Adaptive Control or MIAC is an advanced control strategy that combines aspects of system identification with adaptive control. So kung kanina po sa MRAC, meron po tayong reference model. Sa MIAC naman po ay gagamit po tayo ng system identification. Ano nga po ulit ang system identification? So sa system identification po, ang focus po niya ay building and refining models of dynamic systems based on observed data. So again po ay i-compare po natin yung atin pong input and output data or yung atin pong set point versus the measured value para po makakuha tayo ng model. MIAC integrates system identification into the control process, allowing the system to adjust its control strategy based on updated information about the system's dynamics. So, syempre po, meron pa rin po tayo ditong input and output. Pero po, ang mangyayari sa system identification is, kukumputin po niya yung error in between the set point and the measured value. And then, si system identification po ay magbibigay ng data sa ating adjustment mechanism. Sa adjustment mechanism naman po ay directly na magbibigay ng parameters sa atin pong controller. And then, ito po ay under feedback pa rin ha. So, again po, next po ay categories again ng feedback. We have the dual and non-dual. So, si non-dual po, meron siya ulit forms na dalawa, which is the MRAC and the MIAC. Another technique po for adaptive control is feed-forward. Kanina, feedback. Ngayon, feed-forward naman. Feedback control is a great way to control a system, but some systems experience disturbances that could affect it. So, ito na po, yung mga pagkakataon na meron pong disturbance na nangyari dun sa ating system. Halimbawa po, sa isang temperature control system ng water. So, baka po mamaya bigla po palang nabutas yung ating tangke. Or nagkaroon po ng mga materials or metals sa loob po ng water. A disturbance affects the system in a negative way, but if these disturbances are known in advance, a feed-forward control system can assist the feedback control system to reject or compensate for the disturbances before they happen, reducing the chance for overshoot and corrective action by the feedback controller. So, ang purpose lang po talaga ng isang feed-forward adaptive control ay bantayan yung mga disturbances na nangyayari sa atin pong system. Sa feedback po kasi, is titingnan lang po niya yung relationship between the input and the output. Tapos, magbibigay po siya ng parameters. Sa feed-forward naman po ay i-check po ng ating feed-forward control system yung ating disturbance. Ano po ba yung dapat gawin ni feedback controller para po makapag-adjust siya sa disturbance na nangyari dun sa ating system. A feed-forward system controls outputs based on the disturbances before they can affect the process, but it cannot adjust the output based on measured feedback if the disturbances are different than normal. Kaya po, lagi pong magkasama si feed-forward tsaka po si feedback. Kasi hindi din po kaya ni feedback gumana mag-isa. Ayan, yan po si disturbance na binabantayan po ng ating feed-forward controller. And then, what are the applications po of an adaptive control system? First is aerospace. So, adaptive controllers are used in aircraft and spacecraft to manage changing flight dynamics such as varying payloads, fuel levels, and atmospheric conditions. It can also be used in robotics. They are used in robotic arms and automated machinery to handle variations in work environment, such as changes in load or tool wear. It can also be used in automotive. They can be used to adjust the vehicle speed to maintain a safe distance from the vehicle ahead, even as traffic conditions change. Next po is for manufacturing. Adaptive control is used in processes like chemical reactors, distillation columns, and material processing where parameters may change over time. So, pwede din po siyang magamit in machining or assembly lines na kinokontrol po niya or ina-adjust niya yung parameters for tool wear. Halimbawa, bigla na pong napudpod yung ating drill bit. Material variations or environmental changes. It can also be used in energy systems to help manage the distribution of electrical power in grids, adjusting for load variations and generation changes. For telecommunications, it is used to optimize data flow and manage network congestion in telecommunications network. So kapag po nagkakaroon po ng traffic sa atin pong mga networks such as Globe, Smart, etc. We also have biomedical. It can be used in devices such as insulin pump. So I think familiar naman po with insulin sa mga diabetic po. Next is a pacemaker. So si pacemaker po yung nilalagay sa katawan po or sa puso ng mga taong may sakit sa puso para po matulungan mag-pump yung ating heart. Or prosthetics to adjust their operation based on real-time physiological data and environmental control. Manages heating, ventilation, and air conditioning systems to maintain desired indoor climates despite external weather changes. And then, after po ng adaptive control, ay pupunta na tayo sa intelligent control. Ano naman po si intelligent control? Intelligent control is a term used to describe advanced methods and systems for managing and controlling processes or systems with a high degree of autonomy and adaptability. It often involves the integration of artificial intelligence. So siguro naman po ay familiar na tayo with AI such as ChatGPT, Grammarly, ay ginagamit po natin na Google Assistant, si Siri, si Gemini, machine learning and advanced algorithms to improve performance, optimize outcomes, and make real-time decisions. Ano naman po ang aspects ng intelligent control? First po ay adaptive systems. Intelligent control systems can adapt to changing conditions and environments, kaya nga po siya tinatawag na adaptive. Next is machine learning. By using machine learning techniques, intelligent control systems can learn from past data and experiences to make better predictions and decisions. Next, we have the real-time decision making. Intelligent control systems can process large amounts of data in real time, enabling them to make decisions quickly and efficiently. The next aspect is optimization. These systems can optimize processes to achieve specific goals, such as minimizing energy consumption, reducing waste, or maximizing throughput. The fifth that we have is the human-machine interaction. Intelligent control systems often incorporate user interfaces that allow humans to interact with and influence the system. This can include visualizations, dashboards, and control panels that provide insights and allow for manual adjustments. And the last that we have po is robustness and reliability. Intelligent control systems are designed to be robust and reliable even in the face of uncertainties and disturbances. This ensures that the system remains functional and effective under various conditions. So, napakarami pong aspects ng ating intelligent control. And syempre po, napakarami niya ring uses. And then we have different domains po of intelligent control. First po is neural networks, yung atin pong mismong subject. Neural networks are a subset of machine learning and artificial intelligence inspired by the structure and functioning of the human brain. They are used to model and solve complex problems by learning patterns from data. What are the basic concepts po in neural networks? First, we have the neurons. Ito po yung tinatawag nating neurons. The fundamental units in a neural network. Each neuron receives inputs, processes them, and produces an output. Layers. So, neurons po are organized into layers. The most common types of layers are the input layer, which is the first layer that receives the raw data. The hidden layer, intermediate layers that process the inputs, and the last po is the output layer, which is the final layer that produces the network's prediction or classification. Next domain that we have is machine learning control, which refers to the application of machine learning techniques to control systems, enabling more adaptive, intelligent, and efficient management of complex processes. Hindi ko na po masyadong i-elaborate kung ano yung machine learning control since meron po tayong part na i-discuss din po si machine learning. This approach leverages the ability of machine learning algorithms to learn from data and improve performance over time, often surpassing traditional control methods in handling nonlinearity, uncertainty, and dynamic changes. Next domain that we have is reinforcement learning, or RL is a type of machine learning where an agent learns to make decisions by interacting with an environment and receiving feedback in the form of rewards or penalties. Yan po talaga yung matatandaan natin in reinforcement learning. So, meron po siyang kapalit. It's either reward or a penalty. The goal of RL is to develop a policy that maximizes cumulative rewards over time. So we have the basic concepts po of RL. First is an agent, the entity that makes decisions and takes actions in the environment. Next po that we have is the environment, the external system with which the agent interacts, responds to the agent's actions, and provides feedback in the form of rewards or penalties. Next that we have is the state, or S or ST, a representation of the current situation or configuration of the environment. Next that we have is the action, the choices or moves the agent can make in a given state. And last po, syempre, is the reward, a scalar feedback signal received after taking an action in a particular state. So, kung bibigyan po natin ng halimbawa, tayo po ay magtitrain ng isang aso or ng ating dog. The agent po, syempre, would be the dog. What is the environment? Nasaan po ba currently yung ating aso? Siya po ba ay nasa a park? Siya po ba ay nasa bahay? Nasa cage? Next po is state. Ano po ang current na ginagawa ng ating dog? Siya po ba ay nakaupo, kumakain, nakahiga, natutulog? Next is action. Ano po ba yung mga bagay na ipapagawa po natin sa ating aso na dapat ay may kapalit na reward or penalty? And then the last po, syempre, is reward. So ano po yung magiging reinforcement learning doon? So halimbawa po, yung dog natin ay titingnan po niya kung ano yung mga bagay na kaya niyang gawin. For example, ititrain po natin siya kung paano umupo. So sit. So shake hands. Roll over. Ngayon po, habang ginagawa po ng ating aso yung pag-aaral sa mga actions na yun, syempre binibigyan po natin siya dapat ng reward. So habang tinitrain po natin siya or as time goes by, natututunan po ni aso yung mga actions na sa tingin niya ay nagkakaroon ng sobrang daming reward. So for example, kapag sinabi nating roll over, tapos ginawa niya, bibigyan natin siya ng treat na 3 piraso. Ngayon, sinabi naman po natin sit. Kapag po umupo yung aso, bibigyan natin siya ng 5 na reward. So, sa pamamagitan po nun, yung aso po natin, natututunan niya na kapag ginawa niya pala yung sit na action, doon siya makakakuha ng maraming reward. Yun po, yung tinatawag natin na learned policy. Okay po. Next po that we have is the Bayesian control. It is an approach that applies Bayesian statistical methods to control systems. The core idea is to incorporate uncertainty and prior knowledge into the control process to make more informed and adaptive decisions. So, paano po ba gumagana ang isang Bayesian control? First po is to model the system. So, model the system. Develop a probabilistic model of the system including uncertainties. Next po is to gather data, collect observations or measurements from the system. This data is used to update the model and refine predictions. Next is update beliefs, using Bayesian inference to update the prior beliefs about the system with the new data, resulting in a posterior distribution that reflects the updated knowledge. Control decision. Make controlled decisions based on the posterior distribution. This could involve optimizing actions to achieve desired outcomes while considering uncertainties. Hindi ko na rin po ito masyadong i-elaborate since gumagamit po ito ng Gaussian methods or Gaussian model na ginagamit din po in statistics. And the last po is iterate. So, continuously update the model and control decisions as more data becomes available, allowing the system to adapt to changes and uncertainties over time. Next po, na domain na meron tayo is the expert system. An expert system is a type of artificial intelligence designed to simulate the decision-making abilities of a human expert in a specific domain. It uses knowledge and inference rules to solve problems and provide recommendations or solutions, typically in areas requiring specialized expertise. Kapag sinabi po nating inference, yan po yung pagko-conclude natin. So, gumagamit daw po yung isang expert system ng kanyang knowledge and galing po niya in terms of conclusion. So, what are the basic concepts? First po is the knowledge base. A repository of domain-specific knowledge including facts, rules, and relationships about the area of expertise. Next is the inference engine. So, dyan daw po tayo nagko-conclude the core component that processes information to derive conclusions or make decisions. And then, the last po is user interface, the part of the system through which users interact with the expert system. It allows users to input data and receive advice or solutions. Ano po ba yung pinakamagandang sample na magagamit natin for an expert system? So, syempre, tayo po si user. Magpapacheck up po tayo sa mga doktor or sa hospital. So, syempre, tayo po ay hindi expert since tayo po ay hindi naman po mga doktor. Yung doktor po, yung makakonsider natin na expert or knowledge engineer. So, ang gagawin po natin, isasabihin po natin kay doktor kung ano yung mga na-experience nating symptoms. Ano ba yung masakit, hindi ba tayo makatulog, etc. So, ngayon po, yung doktor, gagamitin po niya yung kanyang knowledge. Titingnan po niya, ano po ba yung mga sakit na possible na related doon sa mga symptoms na nararamdaman natin. Next po is mag-generate na siya ng output. So, syempre, aside po sa knowledge ng ating mga doctors, ay kailangan po natin ng laboratory results. So, titingnan po doon kung magtutugma po ba yung conclusion ni doctor with the results of the laboratory testing. Ngayon po, kung meron na pong result, so, i-explain na po sa atin ni doctor kung ano yung nangyari. So, that is an expert system. And the last domain po of intelligent control is the fuzzy control. So, hindi ko na po siya i-discuss dito since magja-jump na po tayo dun sa atin mismong content. But that po is a picture of a fuzzy control. So, marami po siyang lines. Meron po siya mga trapezoids and triangles. So, I hope po ay wala naman pong question with regards to intelligent control. And then, now po is we will be jumping to the gist of the discussion which is fuzzy logic control. Fuzzy logic control is a form of control system that uses fuzzy logic, a form of many-valued logic, to handle the concept of partial truth. Unlike classical binary logic where variables are either true or false, fuzzy logic allows for more nuanced levels of truth, making it useful for dealing with systems that are too complex or imprecise for traditional control methods. So, sa Boolean logic po, or binary logic, ang pinaka-ginagamit po natin dyan, if magtatanong tayo ng question na, is it hot? Ay, yung mga answers lang po na yes or no, or either 0 or 1. In fuzzy logic po, kapag tayo ay nagtanong ng is it hot, hindi lang po 0 or 1 yung kanyang sagot. Pwedeng very much, fairly so, moderately, somewhat, and very little. And aside po doon is makikita po natin ano ba yung exact value ng mga nakita nating vague na explanation na very little, somewhat, etc. And kung mapapansin nyo po, yung mga numbers naman po in fuzzy logic ay from 0 to 1 naman din po. So, what are the core concepts of fuzzy logic? Paano daw po ba nangyayari ang isang fuzzy logic control? First po is input measurement. Ito po yung laging first procedure in making fuzzy logic control. Involves capturing and interpreting real-world data to be used as input for the fuzzy inference process. This is a critical step because the quality and accuracy of the input measurements directly impact the system's performance and the validity of its decisions or outputs. So, paano daw po ba tayo kukuha ng ating input? So, paano po tayo magme-measure? So, pagka po tayo ay kukuha ng data, it can be from sensors and instruments or measurements. For examples, sa temperature sensor daw po, nakakuha siya ng temperature na 68 degrees Fahrenheit and yung ating humidity sensor na naka-measure ng humidity as 50%. After po ng ating first procedure which is input measurement, ang kasunod po ay fuzzification na tinatawag. So, dito po natin gagawing values yung atin pong input data is the process of converting crisp, precise input values into fuzzy values which are represented by degrees of membership in fuzzy sets. Ano naman po yung tinatawag nating fuzzy sets? These are sets where each element has a degree of membership between 0 and 1. Yan po yung nakikita natin sa baba na 0, 0.1, 0.2, etc. up to 1. So, titingnan po natin ilan po ba dyan ang hanggang 0.4? Ilan dyan ang hanggang 0.2? Membership functions. These functions define how each point in the input space maps to a degree of membership in a fuzzy set. Common types include triangular, trapezoidal, and Gaussian membership functions. Ito po yung tinatawag nating membership set. So, for example, sa low, siya po ay hanggang 0.2 na nagfo-fall linearly into 0.4. Next that we have is medium na 0.45 to 0.6, falling linearly to 0.25 and 0.8. And si high naman po na from 0.8 to 1, falling linearly to 0.65. And the last po are linguistic variables. So, yan po yung mga nakita natin kanina na moderately, somewhat, very little. Pero po, for this case, we have the low, medium, and high. Fuzzy logic often uses linguistic terms to describe variables. In the context of temperature, the fuzzy sets can possibly be cold, comfortable, and hot. So, hindi lang po siya basta-basta yes, no. Pwede po siyang magkaroon ng maraming values. After input, measurement, and fuzzification, ang third step po natin is what we call the rule base. The rule base in fuzzy logic is a critical component of a fuzzy logic system. It consists of a set of fuzzy rules that collectively define the behavior and decision-making process of the system. So, sa fuzzy logic po, kailangan po natin dyan ng rules na susundin ng ating pong system, kung paano po siya gagawa or magko-convert ng data. Each rule in the rule base describes how to make decisions or infer outputs based on fuzzy inputs, and the rule base represents the knowledge or logic required for the system to operate effectively. So what are the components po of the rule base? First po ay fuzzy rules. Yan na po yung talagang rules na ginagamit natin in fuzzy logic. Each rule in the rule base is typically formulated in an if-then format. Si if po ay tinatawag din nating antecedent, specifies the conditions or input variables that need to be evaluated. And the last po is the consequent, which is the then, specifies the output or action to be taken when the antecedent conditions are satisfied. So, for examples po, for rule number 1, if temperature is high, then fan speed is high. So, kailangan po sa isang rule makakita tayo ng if tsaka then. Next, for rule number 2, if temperature is medium, then fan speed is medium. And rule number 3 is if temperature is low, then fan speed is low. Very simple rules lang naman po yung nasa fuzzy logic or yung ating rule-based components. Pero dapat po siya ay consisted with an antecedent and a consequent. And ito pong mga rules na ito ay dapat mo consider sa paggawa po natin ng fuzzy logic control. Next is rule base, the collection of all fuzzy rules that govern the fuzzy logic system. The rule base is used to derive conclusions or control actions based on the inputs provided to the system. I do have here an example po of rule base from the journal of Chatra Mohammed and Fudil Sharif entitled Simulating Virtual Crowd with Fuzzy Logics by 2015. Ano daw po ba yung rules niya? So, meron silang 4 na rules, 1, 2, 3, 4, and meron silang antecedent and consequent or if and then. Ito po ay rules in driving na nakaharap ka sa isang obstacle. So, if daw po, the distance to the obstacle and position of the obstacle, then, saan daw po tayong direction magpo-proceed? If the distance to the obstacle is near, so syempre hindi na po kailangan na kahit na anong position pa niyan kasi malapit na tayo sa obstacle. So ano po ang dapat nating gawin? Kailangan po ba nating mag-go? So tayo po ay dapat nang mag-stop. Kung ang distance daw po natin sa obstacle ay medial or medyo nasa gitna, but the position of the obstacle in the road is on the left, dapat daw po tayong mag-go right. If ang distance po natin sa obstacle is medial or medium pa rin, but the position of the obstacle is in the center, we also have to go right. Bakit daw po kailangan sa right pupunta kahit nasa center? Medyo free po kasi yung right area compared sa left. But if the distance to the obstacle is medial and the position of the obstacle is right, then saan tayo magpo-proceed? So, syempre po tayo ay magpo-proceed sa left. After po ng input measurement, then fuzzification, rule base ay inference engine na. So, dito na po tayo magkakaroon ng mga conclusions. The inference engine is a core component of a fuzzy logic system. It processes the fuzzy rules defined in the rule base and applies them to the fuzzified input data to produce fuzzy outputs. The inference engine uses fuzzy logic operations to evaluate the rules and combine their results, enabling the system to make decisions on or control actions based on fuzzy information. So, what are the key functions po of an inference engine? So, dito po ay medyo marami po tayong formulas, pero hindi naman na po ako magbibigay ng mga computation. Kasi po si fuzzy logic ay alam ko pong ginagawa in laptop. So para ka po nagko-code. So medyo mahirap naman po kung kayo po ay magko-compute manually. So for the first function po of an inference engine we have is rule evaluation. So paano daw po ba natin i-evaluate yung mga rules na meron tayo kanina sa rule base? The inference engine evaluates the fuzzy rules based on the fuzzified inputs. Each rule in the rule base is assessed to determine how well its conditions are satisfied. For the degree of fulfillment for each rule, the degree of fulfillment is computed, representing how much the input values satisfy the conditions specified in the rule. So, ayan po, we have the next function of an inference engine, which is the fuzzy logic operation. So, dito na po papasok yung medyo maraming computation. First po that we have for the logic operation is the fuzzy end, or yung tinatawag nating intersection, or yung pabaliktad na letter U. It combines conditions in the antecedent using a minimum operation to determine the degree to which both conditions are satisfied. So, for the formula, we have the mu. So, bakit po mu ang ginamit natin? Marami po kasing parameter in fuzzy logic, pero ang first parameter po niya is yung mu na tinatawag po natin. Kaya po mu na lang yung ginamit ko. So, the formula po of fuzzy end is the intersection of the mu A and B of x is equal to the minimum of mu A of x and mu B of x. So, ano po yung mga ibig sabihin ng mga letters na yan? So, yung baliktad na U is the intersection, min is for minimum, mu A of x is the membership degree of element x in the fuzzy set A, and mu B of x is the membership degree of element x in the fuzzy set B. So, for example po, if we have the mu A of x na 0.7 and the mu B of x na 0.5, kailangan lang po natin kuhanin yung minimum. Kasi nga po, ang nakalagay sa formula kapag intersection ay minimum. Kaya po, ang mangyayari sa ating consequent na katapat ng ating antecedent ay the intersection of mu A and B of x is equal to the minimum 0.7 and 0.5, and the answer po is 0.5. So, meron po akong photo dito na end. On the first column po, we have the fuzzy set A, and on the second column po, we have the fuzzy set B. So, syempre, titingnan lang po natin yung minimum in between the fuzzy sets, kaya nga po siya ay end. So, for the first row po, the minimum, syempre, between 0 and 0 is 0. The minimum between 0 and 1 is 0. The minimum between 1 and 0 is still 0. And the minimum between 1 and 1 is 1. So, yan po si fuzzy end. Pakitandaan po na kapag fuzzy end ay minimum. Next po na fuzzy logic operation is the fuzzy or yung union na tinatawag natin. Ito naman po yung kabaliktaran ng intersection kanina kasi ito po ay letter U na talaga. Combines conditions or outputs using a maximum operation to determine the degree of satisfaction of at least one condition. Kung kanina po sa intersection ay minimum, sa union naman po ay maximum. So, for the formula, it is the union of mu A and B of x is equal to the maximum of mu A of x and mu B of x, where U is the union, max is maximum, mu A of x is the membership degree of element x in the fuzzy set A, and mu B of x is the membership degree of element x in the fuzzy set B. So, for example, meron po ulit tayong antecedent. If mu A of x is 0.7 and mu B of x is 0.5, then our consequent po is the union of mu A and B of x is equal to the maximum between 0.7 and 0.5, which is 0.7. So, meron din po ako ulit photo. So, titingnan lang po natin yung maximum between the columns fuzzy set A and fuzzy set B. So, for row 1 po, the maximum between 0 and 0 is 0. The maximum between 0 and 1 is 1. The maximum between 1 and 0 is 1. And the maximum between 1 and 1 is 1 pa rin po. And for the third fuzzy logic operation is we have the fuzzy not or yung negation na tinatawag. Kung mapapansin nyo po yung mga logic operations na meron po dito ay yung mga basic logic operations pa rin naman po na pinag-aralan natin before sa coding. Computes the complement of the membership degree to represent the negation of a fuzzy condition. So, yung formula po niya, wala pong minimum and maximum. Pero po, meron po tayong mu a raised to c of x is equal to 1 minus mu a of x, where mu a of x is the membership degree of element x in the fuzzy set A, and mu a raised to c of x is the membership degree of element x in the complement of the fuzzy set A. So, pag sinabi po natin complement, yung kabaliktaran. For example, if we have an antecedent of mu a of x is equal to 0.7, then, yung atin pong consequent ay mu a raised to c of x is equal to 1 minus mu a of x, which is 0.7. Kaya po, ang sagot niya ay 0.3. So, ang gagawin lang po natin ulit sa fuzzy knot ay 1 minus the fuzzy set A. So, for example po, in the photo, I have the column of fuzzy set A. For the row 1, 0. So, ano po ba ang 1 minus 0? Siya po ay 1. So, kung 1 naman po yung ating second row, 1 minus 1 ay 0. That po is not. So, again po, ulitin po natin, ano na po yung mga steps natin in fuzzy logic. First po, we have input measurement. Next is fuzzification. Next is rule-based, and fourth is inference engine. Ang kasunod po ng inference engine ay aggregation. So, medyo malapit na po tayong matapos. Aggregation in fuzzy logic refers to the process of combining the outputs of multiple fuzzy rules into a single fuzzy set that represents the overall decision or action. So, bukod po sa fuzzy logic operations, meron pa rin po tayong computation sa aggregation. Aggregation in fuzzy logic refers to the process of combining the outputs of multiple fuzzy rules into a single fuzzy set that represents the overall decision or action. This step is crucial for synthesizing the results from various rules to determine a final fuzzy output. Aggregation ensures that the contributions from different rules are integrated in a meaningful way. For the first method po of aggregation, we have the union. Siyempre po, ito ay yung tulad ng letter U kanina. And kapag po letter U is ang i-consider po natin ay maximum. The membership degree of the aggregated fuzzy set is the maximum degree of membership obtained from any of the individual fuzzy outputs. So, the formula po is the mu aggregate of x is equal to the max, mu rule 1 of x, mu rule 2 of x, and mu rule n of x, kung ilan po ang ating rules. Where mu rule 1 of x is the membership degree of element x on rule 1, and mu rule 2 of x is the membership degree of element x on rule 2, and mu rule n of x is the membership degree of element x on rule n. And then, we have po the mu aggregate of x, kasi nga po tayo po ay nasa aggregation, is the membership function of the aggregated fuzzy set. For an example po, if rule 1 outputs a membership degree of 0.6 for high, and rule 2 outputs 0.8 for high, the aggregated membership degree for high will be, so hanapin lang po ulit natin yung maximum in between the variables na 0.6 and 0.8, and then, ang answer po natin ay 0.8. Next po, aside po sa union na method ng aggregation is we have the sum. The membership degrees of different fuzzy sets are added together. This method is used when you want to combine the effects linearly. For the formula, kanina po hahanapin natin yung maximum. Sa sum po ay i-add natin sila, pero meron pong word na minimum. So, mu aggregate of x is equal to minimum of mu rule 1 of x plus mu rule 2 of x with 1. For an example, we have an antecedent if rule 1 suggests a membership degree of 0.4 and rule 2 suggests 0.5, then the consequent po is the aggregated membership degree would be mu aggregate of x is equal to minimum na 0.4 plus 0.5 na pareho naman pong binigay na factors, which is equal to 0.9. And then the last po na method of aggregation is the weighted average. We have the union, wherein kukuhanin lang po natin yung maximum in between the different rules. We also have the sum, which is the addition po of the values na meron ang mga rules natin. And the last po is the weighted average. Combines the fuzzy outputs using a weighted average where different rules have different levels of importance or confidence. So for the formula po, we have the mu aggregate of x is equal to the summation of w sub I multiplied by mu rule I of x divided by the summation of w sub I, where w sub I is the weight assigned to the output of rule I. Again po, si w sub I ay yung weight, and the mu rule I of x is the membership degree from rule sub I. So makikita niyo naman po yung mga factors na yan kasi meron naman po silang indicator. For an example, if rule 1 has a weight of 0.7 with a membership degree of 0.5, ibig sabihin po, ang ating w sub I ay 0.7 for rule 1, and ang ating po mu rule I of x is 0.5 for rule 1, and for rule 2, ang atin pong w sub I is 0.3 and yung atin pong mu rule sub I of x ay 0.8. The weighted average is, so gagamitin lang po natin yung formula, mu aggregate of x is equal to the weight assigned multiplied by the mu rule of x, and i-add po natin sila kasi dalawa po yung ating rules, divided by the summation of w sub I. And the answer po, the mu aggregate of x for the weighted average is 0.59. And then, babalikan po ulit natin ano na po ulit yung concepts or yung step-by-step procedure in fuzzy logic. First po ay input measurement. Next po ay fuzzification. Third is rule base. Fourth is inference engine. Fifth, we have the aggregation. And the last step po is what we call defuzzification. So, kapag nagkaroon na po tayo ng variable, ay gagawin na po ulit natin itong crisp value. So, kung titingnan niyo po ng mabuti, si fuzzification ay a crisp value into a variable. Si defuzzification naman po, babalik po natin siyang crisp value. Defuzzification is the process of converting the aggregated fuzzy output, which is represented as a fuzzy set, into a crisp, actionable value. This step is crucial because while fuzzy logic systems can handle and reason with imprecise data, real-world applications often require specific, precise decisions or actions. So, dito po sa mga formula na meron sa defuzzification ay hindi na po ako nag-input ng mga samples. For the first method po of defuzzification, we have the centroid method or the center of gravity. So sorry po, that is off. Calculates the center of the area under the curve of the aggregated fuzzy set. It is the most commonly used defuzzification method. So ito po yung pinakagamit ng klase ng defuzzification. For the formula, we have the crisp output is equal to x multiplied by the mu aggregate of x dx and divided by mu aggregate of x dx, where mu aggregate of x is the membership function of the aggregated fuzzy set, and yung atin pong numerator calculates the moment of the fuzzy set, and the denominator calculates the total area under the curve of the fuzzy set. Next po that we have for the method is the maximum member principle or the max member. Chooses the value with the highest membership degree. This method selects the most representative value of the fuzzy output. So for the formula po, we have the crisp output is equal to the argument x that maximizes mu aggregate of x. Again po, ang basa po sa argmax sub x ay the argument x that maximizes mu aggregate x, where mu aggregate x is the membership function of the aggregated fuzzy set, and the argument x represents the value x where the membership function mu aggregate x is maximized. Third method that we have is the weighted average or mean of maxima. Ito din po yung nabanggit ni Sir Charlton nung nakaraan na MOM. Computes the average of the maximum values of the membership functions weighted by their respective degrees. So for the formula po, we have the crisp output is equal to x sub I multiplied by mu aggregate x sub I divided by mu aggregate x sub I, where x sub I is the discrete value in the fuzzy set. So pag sinabi po natin discrete is, alam natin yung value. And mu aggregate x sub I is the membership degree of x sub I. Kadalasan naman po sa mga values na ito ay pare-pareho lang. Depende lang po sa kung anong klaseng usage. For example, mu aggregate of x, ibig sabihin po, membership degree nung x in a fuzzy set na meron, pero kung x sub I, syempre po, it is the membership degree on x sub I. Fourth po that we have for the method is the smallest value method or the least, kaya nga po siya ay smallest. Chooses the smallest value among those with the highest membership degrees. So for the formula po, we have the crisp output is equal to the minimum of all values x, where the membership degree mu aggregate of x is equal to the highest membership degree identified. Again po, ang basa po sa formula na yan ay crisp output is equal to the minimum selecting all values of x, where the membership degree mu aggregate x is equal to the highest membership degree identified, where mu aggregate of x again is the membership function of the aggregated fuzzy set. Max mu aggregate x represents the maximum member degree in the fuzzy set, and minimum all values of x, where the membership degree mu aggregate of x is equal to the highest membership degree identified, is the smallest value among those that have this maximum membership degree. So kapag smallest po ay minimum, almost same po ng formula with the largest value method or the greatest. Pero po, si smallest or least po kasi ay minimum, while si largest po ay maximum. Chooses the largest value among those with the highest membership degrees. This approach is useful when prioritizing more significant actions. So for the formula po, again, medyo mahaba siya. The crisp output is equal to the maximum all values of x, where the membership degree mu aggregate of x equals the highest membership degree identified. Again po, for the formula, we have the crisp output is equal to the maximum all values of x, where the membership degree mu aggregate x is equal to the highest membership degree identified, where mu aggregate of x is the membership function of the aggregated fuzzy set. Max mu aggregate x represents the maximum membership degree in the fuzzy set, and max all values of x, where the membership degree mu aggregate x equals the highest membership degree identified, is the largest value among those that have this maximum membership degree. So ano nga po ulit ang step-by-step procedure ng fuzzy logic? So first po we have is input measurement. Next is fuzzification. Third is rule base. Fourth is inference engine. Fifth is aggregation. And the last is defuzzification. Ngayon po ay magkakaroon na talaga tayo ng sample na fuzzy logic. Ang sample po natin is medyo basic lang naman po with regards to risk assessment. So, kung paano po tayo mag-a-apply ng credit card. So, first po, sa pag-apply natin ng credit card, ay titingnan po ng mga banker yung ating credit rating. So, i-check po nila kung yung credit rating po ba natin ay pasok or may tatamaan po siyang risk. Ano po yung mga rules na meron tayo for good credit it means low risk. For neutral credit, we have medium risk. And for bad credit, we have high risk. Ano po ba ibig sabihin ng good, neutral, and bad? Kapag daw po good credit, it is greater than 750. Kapag neutral credit, it is less than 750 but greater than 550. And for bad credit, we have less than 550. So for risk assessment po, ang gagawin po natin is, gagawin po natin siyang graph. So tinanong daw po natin yung mga bankers. So paano po, ilan pong percent sa kanila yung sa tingin good na credit ay 550, 750, kasi kailangan po nating gawin na exact value yung crisp output na mga ito. Kasi hindi naman po natin maiintindihan kapag sinabing good, neutral, and bad lang. Ito po yung tinatawag na nating fuzzification kasi meron na po tayong input measurement, meron na tayong data. Ngayon po is ifa-fuzzify na po natin yung atin pong crisp output. Again, the crisp output po that we have is, or crisp values that we have are good, neutral, and bad. So ngayon po, we have the percentage of bankers ranging from 0% to 100%. And ito po yung credit score na sa tingin nila ay good or neutral or bad. So for 300, we have 650, 700, 750, and 800 na credit scores. So ang sabi po dito, 80% po ng ating mga bankers ay nagsasabing good ang credit score na 750. 20% naman po sa ating mga bankers nagsasabi na good ang 700. And aside from that, wala na. So, ibig sabihin si 650, 0 yung pumili sa kanya. Ngayon po, kung pagdidikit-dikitin po natin, ito pong mga dots na ito, makakabuo po tayo ng trapezoid na tinatawag. So, ngayon po, is bubuhin po natin siya. So, syempre, assuming lang po. So, for the green, it is good membership. Next po that we have is neutral membership. Again po, these are all assuming dahil wala naman po talaga tayong exact value. And we have bad membership. Ngayon po, kung titingnan po natin, ang truth ng ating statement ay hindi lang po pwedeng iisa. So, sa fuzzy logic po, pwede siyang marami. Hindi lang po siya dapat true or false. So, for this case po, pwede siyang bad, pwede siyang neutral, or pwede siyang good. Okay po. So, ang masasabi po natin sa 800 na credit score is 100% good. Kasi yung 750 nga po, good na. So, paano pa po yung 800? Ngayon po, paano naman yung 700? Saan natin siya i-consider? Is it good or neutral? Kasi nasa gitna siya eh. Ibig sabihin po, 700 is 50% good and 50% neutral. Ngayon po, paano po kung halimbawa 660 naman yung hahanapin ko? Wala po talaga siya sa mga lines. So, kailangan pa natin siyang i-graph. So, syempre po, si 660 ay lagpas ng konti kay 650. So, kung itatapat po natin siya, ay nandiyan siya. So, si 660 po ba ay neutral, good, or bad? So, si 660 po ay 10% na good and 90% na neutral. Kaya po kung gagawin po nating fuzzified output yung atin pong crisp output na bad, neutral, and good, ang makukuha po natin for 660 na credit score ay 0 bad, 0.9 neutral, and 0.1 good. So, kinonvert lang po siya into decimal. Aside po sa percentage. So, ito po yung tinatawag nating fuzzification. Meron na po tayong fuzzy outputs. Next po that we have, di ba, meron na po tayong value. Gagawin na po natin siyang inference. So, tayo po ay magko-conclude na. Sa tingin po ba natin, ang risk po nito ay ano? So, sa 660 na credit score, so tayo po ay nag-focus na sa 660. Halimbawa po, 660 na yung credit score ng ating applicant, tapos tayo yung banker. Ano po yung masasabi natin sa score na to? So, babalikan po ulit natin yung rules na meron tayo. So, yung good credit po sa ating fuzzy output ay 0.1 pa rin. So, it is a 0.1 low risk. For neutral credit, ang risk po niya ay 0.9 medium risk. And for bad credit, hindi naman po siya high risk kasi nga po, yung value po natin na 660 ay 90% na neutral and 10% good. And hindi po always na ganito, nagkataon lang po na yung atin pong fuzzy output kapag po na inference na ay same pa rin po ng answer. So next po, we have na is a fuzzy variable. Again po, first na ginawa natin is kinuha po natin yung atin pong input, we measured, and the next po ay nag-undergo tayo ng fuzzification kasi kailangan po natin ma-determine yung crisp values na bad, good, and neutral na magkaroon ng exact values. Ngayon po na nagkaroon na siya ng exact value, it is called fuzzified outputs. And kailangan na po natin siyang i-undergo ng inference, wherein magko-conclude na po tayo ng relationship niya with the given rules. Kapag po meron ka na po ulit nakuhang variable, it is called fuzzy variable na. Ngayon, si fuzzy variable, gagawin na po ulit natin siyang crisp value or defuzzified. Ano ba yung 0, 0.9, 0.1? Ano yung risk na meron yun sa mga bankers? Okay po, we have to undergo defuzzification. So, uulit po tayo ulit sa procedure kanina. Magtatanong po ulit tayo ng mga bankers. So, 0% to 100% kung ano po ba yung risk na tinatawag nila. Pero po, for this simple example, so ang percentage lang po niya ay dinivide ko na lang po into 4. We have 25, 50, 75, and 100. And ito po ay assuming lang din po ng mga values. So, let's say po, pag sinabi nating low risk, ang sabi po ng mga bankers ay 25% falling linearly to 50%. Next po, we have the neutral, which is 50% falling linearly to 25% and 75%. And the next po that we have is the high risk in 75% falling linearly to 50%. And then, kung naalala niyo po kanina, marami po akong methods na binigay to defuzzify. Pero po, ang gagamitin lang po natin is yung pinaka-common, which is yung centroid. So, kuhanin po natin yung centroid. Paano po natin ngayon kukuhanin yung center or centroid na tinatawag? Meron po tayong meron po tayong fuzzified variables na 0, 0.9, and 0.1. Gagawin lang po ulit natin yung percentage assuming na ito po siya. So, sa low risk po, ayan, we have 0.1. And for medium risk, we have naman po ay 0.9. Hindi naman po kasi tayo naka-high risk dahil siya po ay 0. Ngayon po, kung titingnan nyo po ay nagkaroon tayo ng trapezoid na pwede nating i-combine. So, kapag po tayo po ay nag-combine, ganito na po yung kanyang magiging itsura. So, ayan na siya, yung color blue. Tinaas ko lang po yung label na medium risk. Now, once merged, the defuzzified value is the x-coordinate of the centroid of this shape, which is about 46%. Everything is all assuming po ha, kasi hindi naman na po ako nag-compute and hindi naman na rin po ako nag-try mag-code. This means that a credit score of 660 is 46% risky, which lines up to the expectation from the fuzzification step. Bakit po? Kasi kung maalala nyo po yung fuzzification step, ang nakalagay po sa 50% na neutral ay 650. So, ibig sabihin po, kung mas mataas yung credit score na meron, hindi po siya ganon ka-risky. Kaya po, ang 660 na credit score ay 46% risky lang po. So, ibig sabihin po, ang fuzzy inference is a way of doing interpolation using vague language. So, from start po na nakita natin na good, bad, and neutral membership ay nagkaroon na po tayo ng exact values. Yun po yung pinaka-purpose ni fuzzy logic. Ayan. Again, I hope wala pong questions and naintindihan po yung discussion ko with fuzzy logic. And then, we have now the advantages and disadvantages of fuzzy logic control. So, for the pros or advantages, we have robustness, handles uncertainty and imprecision better than binary logic systems. Kasi nga po, mas marami siyang factors. Hindi lang siya 1 and 0. Hindi lang siya yes or no. Next po, we have flexibility, easily adaptable to complex systems with vague or imprecise inputs. And next is simplicity. Rules can be written in natural language and are easy to understand and implement. For the disadvantages naman po, we have complexity in design. Designing the rule base and membership functions can be complex and require expertise and computational intensity. So, medyo marami nga po kasi siyang computations. And kung nakikita nyo po, medyo complex kung paano po gawin yung fuzzy logic. Can be more computationally intensive compared to traditional control methods. Yung mga na-discuss po natin kanina, adaptive control, intelligent control, wala naman po kasi siyang computation. Si fuzzy logic po medyo marami. So, kung titingnan po natin, medyo disadvantageous siya sa part na marami siyang formula compared po sa mga nauna. And then, the last po that we have ay yung applications na of okay po, sorry po. So, this is so, ito po ay dapat fuzzy logic control system, hindi po adaptive. So, sorry po, hindi ko lang po siya na-edit. So, first po ay for automotive, fuzzy logic can optimize gear shifting to improve fuel efficiency and driving comfort. Next po ay consumer electronics. An example po of a consumer electronic is a washing machine. Fuzzy logic control various washing cycles by adjusting water level, temperature, and cycle duration based on the load and fabric type. Minsan po kasi sa tingin natin is hindi natin na-encounter yung certain na control system. Pero, sobrang prevalent siya sa atin pong mundo ngayon. And another type of electronics would be air conditioners. Manages temperature and fan speed based on indoor conditions and user preferences leading to more efficient cooling and heating. Next po ay robotics or industrial automation. Helps in tasks like path planning and obstacle avoidance by allowing robots to make decisions based on imprecise or incomplete information. Next po that we have is environmental control. Manages the treatment processes in water purification systems by adjusting parameters like chemical dosages based on water quality measurements. Next po ay aerospace. Helps in adjusting the orientation of spacecraft based on fuzzy logic rules for better maneuvering and stability. Energy management. Optimizes the operation of power plants, including managing load distribution and adjusting generation based on varying demand and fuel conditions. Agriculture. Manages temperature, humidity, and lighting to create optimal growing conditions for plants. Telecommunications optimizes network performance and resource allocation based on fuzzy criteria, helping to manage traffic and ensure quality of service. And last po ay consumer products, which is, for example, a coffee maker. Controls brewing time, temperature, and strength based on user preferences and the type of coffee being brewed. So, ayan po. Kung mapapansin nyo po ay naka-red na rin yung applications since sinama ko na rin po siya doon sa discussion ng fuzzy logic control. And the last po na i-discuss ko for the content ay yung scholarly work na nahanap ko po na related sa fuzzy logic. So I found po this journal sa Wiley Online Library, which is entitled Improved COVID-19 Diagnosis Using a Hybrid Transfer Learning Model with Fuzzy Edge Detection on CT Scan Images. So, published po siya noong August 29, 2024 by Hassan Salarabadi, Muhammad Saber Iraji, Mehdi Salimi, and Mehdi Zoberi. So, ano lang po ba yung pinaka-pinipinpoint ng scholarly work na ito? So, ginamit daw po siya ng mga researchers for fuzzy technique to generate the edge of medical images in the study because the images were of poor quality and the edges were not visible. Nagagamit din po kasi natin si fuzzy logic for the improvement na mga photos. Yung mga medyo malalabo is kaya po niyang mapalinaw. So, sa paper po na ito, the authors introduced a hybrid deep transfer learning approach to analyze a COVID-19 dataset consisting of 300 long CT scans from a hospital in Iran. The dataset is divided into two categories. We have the COVID positive and the non-COVID with a total of 3,900 frames. Approximately 2,400 frames are used for training and 1,500 for testing. So, ang pinaka-point lang po nila dito ay nagkaroon po sila ng mas magandang data since na-ensure po na kung yung tao po ba ay merong COVID or wala. Kasi napalinaw po nila yung images ng CT scans. Initial experiments with CNN models showed overfitting, which was addressed through data augmentation and transfer learning. Yung mga nakita po nila na mga lapses doon sa existing na CT scan from a certain hospital in Iran ay naayos po nila. Minsan po kasi sa mga hospitals ay nagkakaroon ng maling diagnosis dahil po hindi clear yung mga laboratory results or yung mga testings. Utilizing pre-trained models and fuzzy edge detection techniques improved accuracy and reduced overfitting. The authors note challenges such as limited computational resources and ethical concerns related to data privacy and fairness. Future work in this area includes exploring advanced deep learning architectures, using generative adversarial networks for data augmentation, employing fuzzy techniques for better edge detection, integrating multimodal learning, and developing real-time, explainable AI solutions to enhance COVID-19 diagnosis. So, ibig sabihin lang po, from start to finish ay sobrang dami na pong uses ng atin pong artificial intelligence ngayon. Aside po sa control, for example po si fuzzy logic, ay kaya na po niyang makatulong na may ayos po yung mga diagnosis sa mga maling pagkaka-diagnose po in the hospitals because of the poor mechanisms, poor technology. And I hope po ay meron naman pong nag-get sa akin pong discussion for today. And then, ayun lang po. So, pasensya na po for a very long discussion. But, this ends po my presentation. Thank you very much!